Okay, 152. So we're going to rewrite these trig functions, making them more simplified. So let's start with A. I'm going to take the tangent and rewrite that. We know that tangent is the same as sine over cosine. So sine of A over cosine of A. And then we're going to multiply that by cosecant of A. We'll rewrite that one. 1 over sine of A. And then minus sine of A over 1. Okay, there's two things we could do right here. We could make a common denominator here and add those together and then multiply. Or we could distribute. I choose distribute, so I'm going to multiply this times this and write down what I get. I get sine of A on the numerator over cosine sine on the denominator. And then minus, I'm going to distribute here, I get sine squared of A over cosine of A. And then I need to simplify a little bit. I've got a sine here and a sine here. Sine divided by sine is going to cancel, and I end up with 1 over cosine. So I have a common denominator, yay. So I've got cosine of A as the denominator, and 1 minus sine squared of A as the numerator. From the fundamental Pythagorean identity, I could rearrange that to get this. The same is cosine squared of A over cosine of A. And cosine squared divided by cosine leaves just cosine of A. So there's the final result. All of this turns into this, just cosine of A. Let's try the next one. So, step. The next one, I've got cosecant, which is the same as 1 over sine of x. I've got cotangent, which is the same as cosine of x over sine of x. So helpful when you memorize these because makes things faster. Oh, I noticed right here, this has a common denominator, so I'm going to go ahead and put that together as 1 over cosine of x over sine. And then I'm multiplying that by 1 minus cosine of x over 1. Let's multiply across the top and the bottom. Across the top, I need to FOIL distribute this. So I end up with 1. The middles cancel out. A positive cosine with a negative cosine makes 0. And then minus cosine squared over, oops, I forgot the x earlier. Multiply across the bottom, sine x. Now this, according to the fundamental Pythagorean identity, can be replaced with sine squared. So I've got sine squared of x over sine of x. And just like in the last one, sine squared divided by sine, we've just got sine x in the end. So all of that simplifies to just sine x. All right, next, 153. Okay, I'm trying to find the cotangent. I'm given the secant and this fact right here. The reason they give you these facts here is so that you can figure out which quadrant it is. There's 4 quadrants to choose from. It looks like secant is positive and cosecant is negative. So that means it's the quadrant where, because the inverse of secant is cosine, so where cosine is positive and where sine is negative. So which quadrant is that? Well, the only quadrant where that occurs is quadrant 4. So when I sketch this, I'm in this quadrant, quadrant 4. I'm told that secant is 5/4. Well, secant is where we have hypotenuse over adjacent. So that means with Pythagorean triples, this is 3, actually negative 3 in this quadrant because it's under the y, or under the x in the negative y direction. So cotangent is defined then as the reciprocal of tangent, which would be, instead of 3/4, it would be 4/3, and that's a -3, so -4/3 is the result. All right, and to the next problem. This one, it looks very scary. I've got a huge looking problem. Sine squared of that, cosine squared of that equals that. Okay, the nice part is, if you remember the fundamental Pythagorean identity, that says that all of this reduces to what thing? Well, a sine squared of anything plus a cosine squared of the same thing always equals 1. So what we've got is 1 equals 2x plus 3. Let's subtract 3 from both sides. Now it's a very simple problem. And I end up with -2 equals 2x. So x is -1. And that's it. If you remember that fundamental Pythagorean identity, makes this very quick and simple. Okay, next problem. We're going to verify these trig identities. So basically we want this part to simplify to be this, or for this to turn into that. It looks to me like it's better to make this into that. So let's give this a try. We'll just start with part A. Okay, the only thing I can think of here is to make a common denominator. This is one minus sign, that one's one plus sign, so I'm going to need to multiply this by 1 plus sign over 1 plus sign. So when I do that, I'm going to end up with the cosine distributed across that. So it's cosine of theta times the 1 plus sine of theta over this times this, because we've got a common denominator, and these multiplied together make 1 minus sine squared theta, and then this part needs to be multiplied by this cosine, so I'm adding that to a cosine of theta times 1 minus sine of theta. So let's distribute that and simplify. So we've got cosine of theta plus sine cos. Theta's in there as well, plus our cosine of theta minus sine cos. And the one nice part about this is we've got positive sine cos and a negative sine cos that will cancel each other. And so I'm left with 2 cosines. So 2 cosine theta over 1 minus sine. Now I'd like to get all of this in terms of one thing. 1 minus sine is the same as cosine squared. So I've got 2 cosine theta over cosine squared theta. I've got 2 cosines, so if I factor out that 2 and do the cosine divided by one of these cosines, I end up with 2 over cosine of theta. Oops, I meant 2. 2 over cosine of theta, which is actually the same as 2 times 1 over cosine. And 2 times 1 over cosine is 2 secants. And that's exactly what we wanted. All right, let's take a look. Okay, let's change these tangents and cotangents into sine and cosine. So that leaves me with a sine x over cosine x in place of the tangent. In place of the cotangent, that would be cosine x over sine x. Now, I wish they had a common denominator, but they don't, so I'm going to need to make that happen by multiplying this by sine over sine, and this one by cosine over cosine. So that turns into a big 1 over sine squared of x plus cosine squared of x. from sine times sine and cosine times cosine and add them together. That's the numerator. And then the denominator here, sine cos is the common denominator. Next, I can replace all of this with 1. So this is basically a 1 times 1 over sine cos. So I'm going to multiply that by sine cos. And that's what I get. Sine x cosine x is the outcome, which is exactly what we wanted. Yay. Okay, moving on to the next one. Okay, can be a very challenging problem. So this type of problem would be a very good one for a group test, not so much an individual test. Later in the year, this type of question will occur on individual tests. So it's time to get started thinking about it. So this is a situation where we've got a wheel that's on a boat, and there's water level, and the center of the wheel is actually above the water, so part of the wheel goes under the water and part above. The diameter of the wheel is 10, and the center line, so that means from here to here is 5, and from here to here is 8, and under the water is 2 units, and says it takes 4 seconds for it to go all the way around. So if we're taking a look at what's happening, it says that the weed is stuck right here. So it's going to be rotating, it'll go down underwater and then back up in a total of 4 seconds. So what that looks like when we graph that on a curve is, here's the water line right here. And here's the bottom of the wheel, here's the top of the wheel up here at 8. So the weed starts up here and time is passing. At time 0 it's here. Time is passing and it's going lower and lower and lower and lower and lower, and then it goes all the way under water to the very lowest point, and then it goes back up and ends up back at 8. So to me that looks like a cosine curve, where it starts up and then moves down. So it's a right side up cosine curve. The center line of all of this is right here. So that would be at 3. And the amplitude, the distance from 3 to 8, and from 3 down to -2, that is a 5. So we've got a function where, actually it's in terms of t, so let's call that function f of t, where we've got an amplitude of 5, it's a cosine type of curve, and the period goes 4 seconds, so all the way to 4. So we know a normal, let's see, if p is 4, and we know that p is equal to 2 pi over b. So we've got 4 is equal to 2 pi over b. So b is equal to pi over 2. So it's pi over 2 times our t, and then the center line is up 3. So there's the function that models this situation. All right. Let's move on to the next one. Okay, sketch this graph. All right, we've got a line and a curve going on here. So we need to put the two of them together on the same graph to start with. So this is a negative x, so that means it's got a negative slope going like this. So there's the negative x. This one right here, cosine, we start here at 1, go down to -1, start up, go down, up, down, it goes like this. Okay, so what we learned is to put these two together. So I'm going to switch colors to make my actual graph of all of this together. So it's basically, I got a 0 together with the cosine, so I've got a point right here. Here I've got this and then a little bit farther, 0 together with this, so I'm right here. And this one, it's a negative this much together with a negative this much, so I'm going to extend that negative a little bit farther. At this point here, it's 0 together with this value. At this point, I've got a positive with a negative, so it sort of pulls it this direction. And so what's happening here is it's curving like this around the line. And it's going to continue like that the other way. So that's how you would sketch that. All right, the number 158. Okay, it's a piecewise function. So we've got a cubic that's only existing between 1 and -1, and then a value of 1. So if I graph this function, here's my axes. Only from +1 to -1, I have a cubic, and a cubic would go like this. And at 1, where x is greater than 1, it just stays at the value of 1. So that's basically a flat line right there. So this is the sketch of that. And then we've got part B. If our function is shifted, because this is f of x, if we basically move it up 4 units and to the right 3 units, this point right here would move 1, 2, 3, and up 4. So over here, this one would move with it over 3 and up 4. So it's this kind of shape. The whole thing just slides up and over. And then write that as a new piecewise function. Don't forget to shift the domain. So we've still got the cubic. So h of x. Alright, we've still got the cubic going on, but the cubic was shifted. So it's going to be x minus 3 cubed plus 4. And that now exists instead of between -1 and 1. It got moved over 3 spaces, so it's between 2 and 4. And then the value of 1 got moved up 4, so it got moved to 5. And that exists from where x is anything greater than 4. So there's the new function. Okay, this probably will not be on our individual test, but it is good to keep reviewing that because it'll be on the midterm. Okay, and then we're skipping number 159, and so this is our final problem, number 160. Okay, this is another review one. Probably won't be highlighted on our individual test, but it will show up as part of our midterm. So the best strategy here, since we're given these values, is to pull this piece apart using those laws of logs that we learned. This is a times right here, so that indicates adding. This is a divide, that indicates subtracting, and the squared indicates you can move that out in front. So pulling this apart using all of those functions together, I get 2 times the log base b of m plus log base b of n minus log base b of p. And then I can proceed to plug in all of this information. So log base b of m, so I've got 2 times 3.2, and then I've got in place of the log of n, a negative 1.5, and in place of the log of p, I'm subtracting a 2.4. So all we have to do is simplify that. So double this, and we got 6.4 minus 1.5 minus 2.4, and that turns out to be 2.5. And that is the end. That's it.